Hi everybody, and welcome to review session number 1. So today, we are going to be looking at the wonderful world of tricky questions. Yes, these are the questions that evil math teachers put on tests to try and trick you and to make you suffer. So, let's take a look at some of them. We're going to focus on transposing and some inequality stuff and a few other reminders. Let's get to it.
Okay, so today we're going to focus on a topic that always seems to befuddle kids, and they see it and they know it's one or the other. We're talking about all, no, or one. Solution. So which one is it? Well, the typical thing is when you get a question, let's say you had, x plus 2 is 10. All right, so you're already thinking, I know the answer. The answer is 8. So x equals 8. That is one solution. There is only one number that could possibly go where x is that would give you the answer 10. So that's one solution. So that's nice and easy. But it's the other ones, all solution and no solution, that sometimes cause some problems. So let's take a look at no solution first, shall we? So these questions are all going to have the answer of no solution. This means there is no value for x that could possibly make this true. So let's take a look at an example of 11 plus 3x minus 7 is equal to 6x plus 5 minus 3x. By first glance, when you first glance at this, you think, oh, okay, this is just a regular old algebra question. My teacher's done it again. And you wouldn't have an idea that this is going to be a no solution question. So first thing you're going to go and do is you're going to combine like terms on the sides of the equation. So don't forget, there are two sides to an equation, and we combine like terms on each side separately. So there's an 11 and a negative 7. So this negative 7 and this 11, I'm going to combine. So I'm eventually going to get 3x plus 4. And on this side, I'm going to combine my 6x and my negative 3x. And this is going to give me 3x plus 5. So after doing that, this is the statement that I would have. 3x plus 4 is equal to 3x plus 5. Okay, well, let's just think about it for a second before we start putting our math brains on. If 3x plus 4 is on this side, and 3x plus 5 is on the other side, is there any number that I could put in for x on both sides that would make the equation equal? Well, just by using some common sense, the answer is no. Because how could you possibly do that with a 4 and a 5 there? There's no way if they're both being 3x's. And let's go and solve this mathematically. Let's go and prove it. I'm going to go and I'm going to actually subtract 3x from both sides. And you might be saying, but Mr. Douglas, there's no more x's. Well, that's absolutely right. So what we are left with is 4 equals 5. Does that make any sense? Heck no, it definitely doesn't. So it does not make sense. So you're going to say no solution. And that's basically the rule, right? That's the basic rule. If it doesn't make sense, or if it's not true, it's no solution. So what does that look like with inequalities? I'm glad you asked. Let's take a look at this question. 3 times, in brackets, x plus 3 is going to be less than 4 plus 3x. Okay, so we would just start going and solving this, and if you're, a pretty strong math student, you're saying, I'm going to go and distribute that 3 against that bracket, and that's going to leave me with a 3x plus 9 is less than 4 plus 3x. And let's just say, you're got some music on in the background, you're just doing some math, and you know what I mean, you're just doing the operations. You're like, okay, I get this. I'm just going to go and subtract 9 from both sides because I like to do that. And you're just going along. You're not really paying attention. And you get 3x now is going to be less than, what's that going to be? Negative 5 plus another 3x. Like, okay, so now I'm going to go and subtract 3x from both sides. Cool. And you're just going along. Maybe the next track comes on in your headphones. And now you get to hear, you're like, whoa, wait a second. What happened? Where did all my x's go? I guess I write 0. Okay, well, then 0 is less than negative 5. I have no more x's. Uh-oh. Okay, well, let's see. I watched my teacher's video, so I know this now. Is this true? Is 0 less than negative 5? No, 0 is actually bigger than negative 5. So this is false, which means for inequalities, this is no solution. So if it's not true, when you look at the statement, then you're going to write down no solution. You can't graph it. Absolutely not. That's all you write, and there you go. Now you're wondering, well, if that's no solution, what would all solution look like? I'm glad you asked. Let's take a look at what all solution would look like for inequalities. Here we go. Let's say you had x plus 6 is greater than x plus 4. Okay, so we're going to go and solve this one. I'm going to subtract 6 from both sides. And now I'm going to be left with x is greater than x minus 2. And I'm going to go and subtract x from both sides. And that is going to leave me with, uh-oh, my x's all disappeared. 0 is greater than negative 2. Ask yourself, is that true? Well, it certainly is. It is true. And if an inequality is true, and you have no variables involved, your answer would be all solutions, or all real numbers. And that's what you would have to write. Now, there's also another fancy term. The other fancy term for this would be called an identity inequality. So you might see some people trying to show off all their math knowledge and say, I know what an identity inequality is. Maybe actually you can go see mom and dad right now and say, hey, mom, dad, do you know what an identity inequality is? And they'll probably look at you strangely and say, no, I don't. And then you can say, well, I could explain it to you if you maybe let me stay up late, or maybe can get some junk food or some candy on the weekend. You know, bargain with your parents. And you can show off some math skills as well. So that gives you a little bit to know of what that would look like. And we talked about one solution at the start. We've talked about no solution and all solution. So that kind of summarizes those sorts of things. There's one more thing I'm going to show you, guys. There's one more I'm going to show you. And I'm going to show you the question that math teachers often put on tests. So here's the question that math teachers put on tests. And I'm going to ask you, is this one, none, or all solutions? Which one is it? And here we go. 6x plus 2 is going to be less than or equal to 10x plus 2. And if we go and we do this question, what's going to happen? Let's take a look. I'm going to subtract 2 from both sides. And you know what? I'm going to do 2 steps at once. It's going to be crazy. And I'm going to subtract 10x from both sides. Awesome. And then what all happens here? I get negative 4x is going to be less than or equal to 0. A lot of times when students see the 0, they start thinking it's no solution or something bad is going to happen. Well, this is a great question because if you had to go and solve this one, so finish solving it, I'm going to divide both sides by -4. And this is extremely important because don't get thrown off by that 0 right there. So some students do. So you had to divide by -4 on both sides. And maybe you're thinking, I already know that if I divide something like 0 by -4, it's just going to be 0. I know that. Well, you still have to do that. And why, and a lot of students forget this, is because you need to go and flip that one. This is a great question because now the answer is x is greater than or equal to 0. A lot of students forget to flip that inequality. So what kind of solution is this one? This one is just a 1 solution, but it's very tricky because it has that flipping rule with the inequality. Let's look at one more tricky question. I'll give you guys a bonus tricky question. And this is the bonus tricky question, and I'm going to make it super easy. When you look at it, x plus 7 equals 7. And you go and you solve it, and you obviously subtract 7 from both sides. And realize that this is not an inequality, this is now an equation. And you end up getting x equals 0. Now, 0 does not mean no solution. Okay, that is not what it means. It means 0. 0 is a solution. This is one solution. One solution. Poor 0. 0 gets confused all the time. A lot of students think that when you get x equals 0, that means no solution. Because, 0 doesn't really have any value. So they write down no solution. No, no, no. This is one solution, and that one solution happens to be 0. All right, so there's one of your common kid mistakes that I'm trying to identify for you. Hint, hint, pay attention. On to another topic, and this topic is going to be about literal equations, or also known as transposing. It's one of my favorite topics because this really shows if you understand the rules of algebra. So let's take a look at a couple things. The first one is going to be x is equal to wz all over a. And we're going to solve this one for w. Now, this is a classic kind of question. You see no numbers, so it's instantly already scary. And I'm going to show you a couple things that I always do. When you see a question like this, I love to even out questions that involve fractions, so everything is a fraction. So I like putting it over 1 because this gives balance. And we know we always want balance in the force. So I always do that. And a couple things is once you see a fraction equaling another fraction, you should be thinking about cross multiplying. That should be the first thing that kind of pops in your head. So we're talking about this kind of stuff. If I want to cross multiply, that's what you kind of be starting to think about. So if we go and we cross multiply, we go x times a, and we get ax, or maybe xa, but I'm going to say ax, and 1 times wz, yes, it's z, is going to be wz. There you go. Now I want to solve for w, so you have to ask yourself, how do I get rid of this z there? Well, don't forget, this is saying w times z. So there is an imaginary multiplying sign there. And if you think of what's the opposite of multiplying, which is dividing, I'm going to divide both sides by z. And if I do it to one side, I do it to the other side. And what that does is it goes and eliminates my z's, and it leaves me with the w. So my final answer is w is equal to ax all over z. So one little thing kind of there with some transposing. Let's take a look at another one. Now this one is a fun one. This one causes all sorts of confusion. We'll stay with the letter of z, and we'll make it equal to w times, in brackets, an x plus 2, and outside the brackets, we'll add another 2x together, just for fun. And we're going to solve this one for the classic x. Okay, there's lots of different ways you can go about this. Some students, I think most students, when they see brackets and they see something in front of it, they always usually want to go and open up the brackets. Now, that's not always a good thing to do, but in this case, I'm going to go ahead and do that. And I'm going to get wx plus 2w. And don't forget about the other 2x there. Always asking yourself, could you combine any like terms on this side? Nope, there's nothing that is exactly the same. So when you look at it now, though, you're like, uh-oh, well, there's an x there, there's an x there. That seems confusing. And what you want to do is you want to get your terms with the x's on one side. So you should be saying to yourself, okay, I want to leave wx, I want to leave 2x, but I want to get rid of this 2w. So how do we go and get rid of that 2w? So I'm going to go and I'm going to subtract the entire 2w. And I'm going to do that to both sides. So now what I end up getting, I'm going to write it this way, is z minus 2w. Oops, did I just say, yeah, I'm doing that right. Equals minus 2w equals wx, I almost got confused there for a second, plus another 2x. Okay, so good job. You've gotten the right-hand side with the terms that have x's on them. Now you have to do something called factoring. So I'm going to factor out an x. So a quick little review. If you had something that looked like this, 2 bracket x plus 4, if you went and distributed this, you would get 2x plus 8. If you did the backwards process, you took out a common factor. So you went backwards. You went from 2x plus 8, and I asked you to factor it. You would factor out a 2, and you say, well, what's left? What would be left inside that? So 2 times what gave you 2x? X. 2 times what gave you 8? And that's 4. Okay, so I want to do that process here, but with my x. So I'm going to factor out my x. And if I factor out my x, what's left is w plus 2. And don't forget this still, of course, equals z minus 2w. And now I want to get my x all by myself. So how can we go and do that? I'm going to divide both sides by a w plus 2. And this one by a w plus 2. What that's going to do is it's going to eliminate my w plus 2's and just leaves me with my little old x there. And I know this looks kind of weird and scary, but that's your final answer. X is equal to z minus 2w all over w plus 2. Seems ugly and scary, but that is hardcore classic algebra coming right at you there. So that's it for today. And we've taken a look at quite a few different things. We have looked at types of solutions. So one, none, or all solutions. And we took a look at some, the good old common kid mistakes of those. And then we also took a look at transposing. And through all of this, we even, tossed in some inequality stuff like that. A lot of stuff going on, pretty quick. If you have any questions, feel free to always contact me. And until next time, keep on doing your math.
Thanks everybody for tuning in. Until next time, good luck on your math tests.